Here's another example of a projectile motion problem. Again, remember that if you're going to solve projectile motion problems, you're going to need these two equations for sure, and sometimes also these two equations of kinematics. All right, let's read the problem. A soccer player kicks a ball at a 2.4 meter tall goal from a distance of 30 meters. She kicks the ball at an angle of 10 degrees above the horizontal and with a velocity of 25 meters per second. Will she make a goal? All right, that sounds like a pretty fun problem. Let's write down what's given. First of all, they tell us that the goal is 2.4 meters tall, so the height of the goal is equal to 2.4 meters. The distance from where she kicks the ball to the goal is 30 meters, so that's x equals 30 meters. She kicks the ball at an angle of 10 degrees, so we took care of this. Now we have this information, so the angle is 10 degrees. And finally, the initial velocity is 25 meters per second. V initial equals 25 meters per second. So we've made the list of all the things that were given. And the question is, will she make a goal? So let's draw a picture so we can kind of figure out what it is that they're finally asking for. So here's the player kicking a ball with an angle of 10 degrees, theta equals 10 degrees above the horizontal, with initial velocity, V initial equal to 25 meters per second. The ball will travel like this towards the goal, and let's say here's the goal. Here's the goal box and the penalty box. All right, so I suppose the question is, will the ball go into the goal? Will the ball go too high and too fast and go over the goal? Or maybe the ball wasn't kicked far enough or hard enough and the ball will hit the ground before it hits the goal. Which of these three scenarios is it? So maybe the way to approach this problem would be to say, when the ball reaches the goal, what will be the height of the ball? So in this case, what will be the height, or what would y equal when the ball reaches the actual goal? So the question then would be y equals question mark when the ball reaches as far as the goal. Now, what if the ball wasn't kicked hard enough and the ball hits the ground before it hits the goal? Well, theoretically in mathematics, the ball would continue underneath the ground, and when it reaches the goal, there would be a negative height to the ball. That would be the way to know that the ball didn't quite reach the goal. All right, let's go ahead and start with this problem. We have a nice little drawing, so we have a good pictorial of what's going on with the problem. We wrote down what's given. We've determined what's being asked. What's the strategy? What do we do next? And again, since it's a projectile problem, we probably want to start with saying time in the air is equal to question mark. That's what we're looking for. Once we know the time in the air, we can calculate how far the ball will go or how high the ball will be when it reaches that. Let's see here. In this particular case, we can't really use the vertical component of the velocity to figure out time in the air because we don't know how high the ball will be when we reach the goal. But we do know how far the ball has to go to reach the goal. We were given that the distance, x, is equal to 30 meters. So instead of using the vertical component to figure out how long it stays in the air, let's use the horizontal component. Let's assume that the ball will reach a distance of 30 meters, and how long will it take the ball to do that? Of course, since the ball is kicked at an angle, not vertically or horizontally, we need to figure out what the vertical and horizontal components are of the initial velocity. We need to figure out what v initial in the x direction is, and we need to figure out what v initial in the y direction is. And again, since this is adjacent to the angle, this is equal to v initial times the cosine of the angle, and this is opposite to the angle, so this is v initial times the sine of the angle. And plugging in what those numbers are, v initial would be 25 meters per second times the cosine of 10 degrees, and this would be equal to 25 meters per second times the sine of 10 degrees. And then if we grab our calculator, we can figure out what these are. So we have 25 times the sine of 10, and that would be 4.34 meters per second in the vertical direction. And over here, we have 10, take the cosine of that, and times 25, and that's 24.6 meters per second. So now at least we've got the initial vertical and horizontal component of the velocities. All right, time in the air. We're going to use the horizontal component, so we write x equals x sub naught plus v sub naught in the x direction times time plus 1/2 at squared. In this case, there's no forces acting in the horizontal direction, so there's no acceleration in the x direction. The initial distance we can assume to be 0 at time equals 0, so this equation becomes x equals v initial in the x direction times time, or solving this equation for time, dividing both parts of the equation, both sides of the equation by v initial in the x direction, we could write t is equal to x divided by v initial in the x direction. Okay, what are those? X is 30 meters, and v initial in the x direction, right here, is 24.6 meters per second. Notice here that meters divided by meters cancel out, and 1 over seconds becomes seconds. So t equals 30 divided by 24.6 equals 1.22 seconds. That's the time in the air. All right, now that we know how long the ball will be in the air, by the time the ball reaches the goal, how high will the ball be at that point? And so we're now going to use this equation to figure out the final height. So we have y equals y sub naught plus v sub naught in the y direction times time plus 1/2 gt squared. Plugging in all the variables that we know. The initial height, well, starting from the ground, would be 0 plus initial velocity in the y direction, which we calculate right here, 4.34 meters per second, times the time we calculated right here, which is 1.22 seconds, plus 1/2 times g. Remember, g is a negative 9.8 meters per second square, times the time squared, and the time was 1.22 seconds, quantity squared. Okay, simplifying our variables, we have seconds here and seconds there. We have a 1 over second square, and this would be squared, so this is second square and second square. That cancels out. And now let's calculate what that is. Y equals, this first part would be 4.34 times 1.22. So it would be 5.29 meters. And that would be minus, calculating that part, we have 1.22 squared times the 9.8 and times the 0.5 equals, that's minus 7.29 meters. And so if I take 5.29 minus 7.29, that would be minus 2.00 meters. Final height of the ball, 2 meters below the ground. Now, of course, that is not realistic. What that means in this particular case, the ball didn't go far enough, hit the ground before it hit the goal, and so I would say the goal would not be scored unless the goalie standing in front of the goal doesn't grab the ball when the ball bounces back up, and maybe that way the goal is scored. But realistically speaking, if the goalie was standing at the goal line, the ball would hit the ground before the goal, and the goalie would probably stop the ball. But the answer, no, I would say she will not make a goal.